In this lesson, we're going to look at something called slope, which is working with how much of a slant a line has or doesn't have. The change in y as we move from one point to another is called the rise. The change in x as we move from one point to another is called the run. The slope of a line is the ratio of the change in y to the change in x, and the grade of the road is a measure of how steep it is. We do have a couple formulas to think about when it says ratio of change in y to change in x, or you can think of it as rise over run. And then we have a more specific formula that we'll look at in a few problems, and it's also going to be on your formula sheet. So let's look at these graphs and see if we can identify the slope. The slope, you just need 2 points. It doesn't matter which 2 points. So in number 6, just pick any 2 points on the line. They have 4 picked out. We'll just go ahead and pick this one here, and we'll do this one here. So if we're going to find our slope, and slope is identified, we use m to represent slope, which sounds kind of strange. I believe it has something to do with the French word for slope, but I'm not real sure on that. But it's rise over run. From one point to the next, we have to decide what's the rise, how much of a change is happening between the 2 points. So from this point up is how much, because that's going to be your rise, and that is going to be 1, 2, 3, 4, 5, looks like 6. And now, from the point this direction, how far is that? And it looks like it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Now my lines are slightly off. So let me see if I can draw them a little bit better. But 6, the rise of 6, so I count up 6. And I counted to the right 9. So our rise is 6 over 9, which would reduce to 2/3. So slope is 2/3. So now let's look at these 2 lines. They're similar, one's horizontal, one's vertical. So think of the same thing, rise over run. So from one point to the next, from this point up to this point, we have a rise of 1, 2, 3, 4, it looks like 5. Now, my run is my horizontal movement. There is none, which is 0. So 5 over 0, we say is undefined. So the slope of this line is undefined. So what do you think the slope of the next line is going to be? If again it's rise over run, I have from one point to the next, I don't have a rise at all because it's a horizontal line. And from my point to here, I have 1, 2, 3, 4, 5, 6, 7. And it actually really doesn't matter because it's going to be 0. So my slope here is 0. My slope on the previous line was undefined, and my slope of the very first one I did was 2/3. To kind of sum this up, there's 4 different scenarios that can happen with slope. You can have a positive slope, like I do in number 6, We can have a line with a negative slope, which is slants in the opposite direction. We can have a horizontal line has a slope of 0, and a vertical line has our undefined slope. So we have positive slopes, negative slopes, 0 slopes, and undefined slopes. You're going to have one of those 4 scenarios that happen in all of your slope problems. So let's graph the line. They give us 2 points, so that's easy. We don't have to come up with the points on our own. -4, 2, so -4, 2, and 1, 0. And I'm going to draw my line. That's pretty close. So graph a line and find the slope. So slope, again, is rise over run. So if I pick my 2 points and I count my rise and my run, I'm going to start with the point on the left. I actually have to go down. And since I'm going down 2, that's like a -2. And then I go right. 1, 2, 3, 4, 5. So it looks like I have a -2/5 slope. Now on this one, find the slope if it exists of the line containing the given pair of points. So do we have to graph it and count? No, we don't. We actually have a formula that we can use for slope. And it looks a little strange, so I'm going to go ahead and write it down. And again, it can be found on your formula sheet. The 1s and 2s just represent like point. So we could call this 0.1 and we could call this 0.2, but it really doesn't matter. What it says is we are going to subtract our y coordinates in the numerator and subtract our x coordinates in the denominator. So if I subtract my y coordinates, that's going to be 5/4 minus -1/3, or you could do -1/3 minus 5/4. You just have to be consistent. So if I start with 0.2 and I start with 5/4 in my y's, and that means I have to start with -2 in my x's. So -2 minus 3. So 5/4 minus -1/3, 19/12. And I would recommend just doing that in your calculator. You can do it by hand if you like. And -2 minus 3 is -5. And so it looks really weird, but when you do your final division, 19/12 divided by -5, you're going to get -19/60, which is going to be your slope. Now, another way to identify slope is directly from the equation. You don't have to necessarily find 2 points from the line, although you can, and use the formula. We have a form of a line, a general form, which is y equals mx plus b. And if it's in this form, the slope is always going to be in front of your x term, as long as the equation is in this form. So when we look at number 15, it's set up perfectly. There is no work involved, and our slope, so m equals -6. If I found 2 ordered pairs for that line, which I've been doing the last few lessons, and I did the formula on them, I would get m equals -6. So that works great for equations that are in that form, but what about number 16? How do we do that one? Well, if it's not in y equals, treat it like a formula and put it in y equals. So I would need to move my x term to the other side because it has to be on the right. So that's going to give me -y equals, now I have 2 minus 5x. The form of our slope-intercept form is the x term comes first. So -5x plus 2. And then we don't want -y, we want +y. So I actually have to go through and divide everything by -1. and that's going to give me y equals negative 5x over negative 1, and negative over negative is a positive 5x, and then 2 divided by negative 1 would be negative 2. So my slope ends up being 5 because that's the number in front of the x. So if you look at the next one, number 17, this is kind of a trick problem. But recall that if it's one variable, it's either horizontal or vertical. Well, our options for slope, if it's horizontal or vertical, is either a 0 slope or an undefined slope. So how do you know which is which? Well, if it's x equals, that means it must cross the x lines, or x-axis, so that makes it a vertical line. And vertical lines have an undefined slope. If it was y equals 5/9, then it would be slope of 0 because it'd be a horizontal line. So just like number 20, what's the slope of that line? Well, if you think of it graphically, you're going to have a horizontal line because it has to cross the y-axis. So that has a slope of 0. 21, is that in the proper form, y equals mx plus v? Absolutely. It's y equals. As long as it's in y equals, you're fine. So what's your slope? Well, it's always going to be right in front of your x if it's in y equals form. So my slope equals 13.8.